Hello students, how are you all doing? Hope that you must be fit and well. Today we are doing a sum from JEE Advanced 2016. The sum reads like this. A solution curve of the differential equation x squared plus xy plus 4x plus 2y plus 4 dy by dx minus y squared equals to 0, x greater than 0, passes through the point 1, 3. Then the solution curve given options are A intersects y equals x plus 2 exactly at one point, intersects y equals x plus 2 exactly at 2 points. C intersects y equal x plus 2 whole square. And D does not intersect y equals to x plus 3 whole square. Now it is being told to us that there may be more than one option correct for the given question. There may be, so out of these 4 given options, there may be more than one. Okay, one or more than one may be the correct option. Okay, so we have to select all the correct options. Okay, and if you make a mistake, okay, one is correct and another you have ticked a wrong option, so you will get minus marks. Okay, so you have to either when you are putting the correct options, so you have to make all the correct options. Okay, and one right and one wrong will be a minus mark. Okay, but one correct and nothing wrong, you will get some marks. Okay, so now see here how we'll do the sum. Okay, so here you have to understand the question. Okay, first very clearly. See here. Here it is given to us that this is the differential equation of the certain curve. Okay, now it is saying us that when we solve the differential when we make a solution of this differential equation, what we get the equation of the curve. Okay, so that equation of the curve passes through this point 1, 3. It is being told to us, and then it is asking that curve whose differential equation is this. Okay, so that curve we have to check these given options, 4 options about that curve. Okay, so first we have to find the equation of the curve whose differential equation is given. Okay, by the solution of this differential equation. So first we will solve this differential equation and get the equation of the curve. Okay, so here, see here. Now how we will solve this differential equation? First we will change this differential equation to linear differential equation. Now see how we are changing. See here it is given this is the differential equation. Okay, x squared plus xy, okay, plus 4x plus 2y plus 4, okay, dy by dx, okay, minus y squared is equals to 0. This is the differential equation. Now see here. Now you notice that x squared, 4x and 4, okay, together what they are making? They are making x plus 2 whole square. So x plus 2 whole square is x squared plus 4x plus 4, and from here you take y common. Okay, so this and this I am taking y common. Okay, so when I take y common, so from here there will be x left and from here there will be 2 left. Okay, and dy by dx and minus y squared I am taking to that side. It will become plus y squared. Okay, now here we are getting x plus 2 whole squared plus y into x plus 2. Now here dy by dx I am taking that side. Okay, so this will become dx by dy. Okay, dx will go up and dy will come down. Now we are putting let, okay, x plus 2 as t. Let x plus 2 equals to t. Suppose, okay, so what we are getting from here, if we differentiate both the sides with respect to x, so differentiating with respect to y, differentiating both the sides with respect to y, okay, so what we get here, dx by dy, and 2 is the constant, it will, a differential coefficient will be 0, will be equals to dt by dy, okay. So here dx by dy will be equals to dt by dy. So here in place of dx by dy, I am writing dt by dy, okay. So what we get now, okay, so here x plus 2 I have put t squared. So here it will be t squared plus here x plus 2 is t. So ty is equals to y squared, and this become dt by dy. Okay, I have showed you dx by dy is equals to dt by dy when we are putting t is equals to x plus 2. Okay, now see here, we have substituted x is equals to, so what we have substituted, I am writing here, okay. So t is equals to x plus 2, because we will again change it to the original form, okay. So we will not write the equation of the curve in the form of t, we will change again to the original form, okay. So we have to remember this. So t is equals to x plus 2. Now see here, so now divide throughout with, first you divide throughout with y squared. So when I am dividing throughout with y squared, so what we will get, t squared by y squared, and here ty if I divide with y squared, so what will I have get, here t by y I will get, and here y squared will be cut out, so dt by dy we will have, okay. Now see here, again what we will do, okay. So now here what we are now doing, now I will divide throughout with, okay, t squared, okay, then we will get a differential equation, linear differential. Now divide, because linear differential equation is of which form, see here, linear differential equation is d, like this type of form, dy by dx plus py is equals to q, where p, whatever is the differential coefficient here, okay, that here it will be py plus q, here it is dy by dx, here it will be py equals to q, where p and q are the either the constant terms or the functions of x alone, okay, not the functions of y, okay. Now see here, so we have to remove t squared, okay. Now see here, I am dividing throughout with t squared, so what we will have here, it will be 1 by y squared plus here t squared, if I divide by t squared, so what I will have, 1 ty, okay, and here it will be 1 by t squared dt by dy, okay. Now see here, now what we are doing, for changing this equation into this form, okay, we have to remove this, okay. Now see here, how I will remove here, and remove here, okay, this also, and here t should be carried to the top, okay, not in the denominator. So substitute here, let okay, 1 by t, I am minus 1 by t, I am putting as z, let minus 1 by t is equals to z. So differentiate both the sides. Now differentiating, so what I have put, I am writing here, minus 1 by t is equals to z I have substituted, Okay, so differentiating with respect to y on both sides. On both sides, if you differentiate with y, so here what will happen? Here it is c here. Here it is 1 by t. So that is t to the power minus 1. So minus 1 will come down. So minus into minus will, okay, will become plus. So this will become 1 by t squared dt by what? dy. We are differentiating with y. Okay, dy is equals to dz by dy. Okay, so here I will have, okay, minus 1 by t, differential coefficient will be 1 by t squared. So 1 by t squared dt by dy is equals to dz by dx. So here in place of 1 by t squared dt by dy, I will put dz by dy, and 1 by t I am putting minus z. Okay, so what I will get here, so I am writing this side. So 1 by t squared dt by it will be become dz by dy. Okay, and here it will be 1 by t. So 1 by t is, okay, plus 1 by t will be minus z. Okay, so that will be minus z by y. Okay, and plus 1 by y squared. Clear? So that is 1 plus 1 by y squared. Right? Now see here. Now what we are doing here, now bring all the terms this side to the right hand. Now this here z I will bring it. So I will get this equation will change into linear differential equation. I am bringing this side and this I am putting there. Okay, so this will become dz by dy plus z by y is equals to 1 by y squared. So this has changed into the linear differential, which is the linear differential equation. Okay, so linear differential equation here. Now you compare with it. So here this is the function of y. Okay, and this is q in place of see, q is 1 by y squared and p is 1 by y. Okay, and dz by dy here. Okay, so what is the integrating function, integrating factor? So here integrating factor will be e to the power, okay, p dy. Okay, so here it will be 1 by y, okay, dy. So dy by 1 by y, integration of that. So dy by y is equals to what? Log y. Okay, so it is equals to, okay, e to the power mod of log y. So that is equals to mod of log y. Okay, so the integrating factor is equals to log y. Okay, so this is equals to log y. Correct? So here what we will have now, so it will become what will be the solution of the differential equation. So the solution of the differential equation will be okay, oh sorry, e to the power log any quantity, sorry, e to the power log any quantity is equals to that quantity. So it will become y. Okay, integrating factor e to the power log y is equals to y. So the solution will be what? So solution will be y into z. Okay, integrating factor into z will be equals to integration of 1 by y squared into y dy plus c. So cancel here, y and y gets cut out. Okay, so what we are now getting? Okay, so now we are having here, okay, so what we are getting now here, yz is equals to dy by y plus c. Okay, so here yz is equals to integration of dy by dy by y becomes what? Log y. Okay, so that is log of mod y plus c. Okay, so that we get. Now change it into the original form. In the given question, there was not Z, T, such on. So we'll now change back into the original form. So we will put now for Z, I am putting minus 1 by, here it was, T was x plus 2. Okay. For Z, I am putting minus 1 by T. Okay. So this will change to, okay, so this will be y by minus y by t. For Z, I am putting minus, okay, minus 1 by t is equals to log y, okay, log of mod y plus c. Now t is what? T is equals to x plus 2. Okay, so in place of t you write x plus 2. So we are getting minus here x plus 2 is equals to log of y plus c. Now this is the differential, means the equation of the curve. Okay, but we will change it into the, this is the general, we'll change it to the, means pre from c. Okay, now how will make this pre from c? Because it is being told to us that this curve is passing through the point 1, 3. Okay, so this curve is passing through the point 1, 3. So in place of x in this equation you put 1, and in place of y you put 3. Okay, so here because this curve, okay, now you will write because, okay, putting because the curve, okay, because curve 1 passes, okay, passes through the point P1, 3. So this point will satisfy this equation. Okay, so in place of y you put 3, and in place of x you will put 1. So this will become minus 3, and here I am putting 1. So 1 plus 2 will be 3 is equals to log, here y you put 3, log 3. So log 3 plus c. So 3 is a positive number, so that will be log 3. Okay, so here mod sign will be removed. Clear? So we will have here 3 by 3 is minus 1. Okay, here is equals to log 3 plus c. Correct? So what is the value of c? The c value is log is 3 is going this side. So minus 1 minus log 3. Okay. Now 1 is what? 1 we know. 1 is log e. Log e value is 1. So in place of 1 I am writing log e. So this is minus log e. Okay. Log e minus log 3. Okay. Log 3. So c is equals to taking minus common. So this is log e plus log 3. So log e plus log 3 change into 1 log. This will be multiplied together. So this will be log 3e. Okay. So now in place of c we will put this. Okay, minus log 3e. Okay. So the equation of the curve will be what? Equation of the curve will be minus y by x plus 2. In place of c we will put that value. So this is equals to log mod y plus, here it is minus log 3e. Okay. Now see here. So we have got this thing. Okay. Now you change the sign. So this is the equation of the curve we have got. Okay. Now you change the sign throughout. Okay. So this minus is changed to plus. So y divided by x plus 2 is equals to, this will become plus. So minus log 3e and plus log y will become minus log mod y. Correct? And log 3e minus log mod y changed into 1 log. It will become 3e divided by mod y. Okay. Now here what we are getting then? Okay. So now what we know the property of the log? If, see, we know the definition of log. If a to the power m is equals to n. So the log n to the base a is equals to n. Okay, so now if we change into the back, so this will become in this form. Okay, so we will have 3e divided by mod y, okay, will be equals to e to the power, so any here base is not given, so base is e, so that will become e to the power y divided by x plus 2. Okay, so here log 3e divided by mod y is equals to y by x plus 2. So 3e by mod y will be changed into will be equals to e to the power y by x plus 2. Base here to the base raised to this power. Okay, so this is the equation of the curve. Okay, this is the equation of the curve whose differential equation is this. Okay, now see here. Now what we are doing, I will taking this mod y this side. So this 3e is equals to mod y into e to the power y divided by x plus 2. So this is the equation of the curve whose differential equation was given to us. Okay, so I hope that you must have understood this differential equation, how we have got the solution of the differential equation. Now we will check the given options now. Now see here. So first is telling that this y is equals to x plus 2 intersect this curve. This is the curve. Okay, we have got whose differential equation was this. Okay, now it is telling that this line y is equals to x plus 2, this line is intersecting this curve. Okay, at A is saying 1 point, B is saying 2 points. So let this equation be the equation 2 because earlier we have taken 1. Okay, now here, now we have to check this. So if this line, equation of this means equation of the line satisfy this equation. Okay, so what will happen? This equation will satisfy. So in place of y, I can write x plus 2. Okay, so putting y is equals to x plus 2 in equation 2. So what we will have here, we will get 3e is equals to, in place of y, I am writing, okay, x plus 2 into e to the power y. Y is what? X plus 2. Okay, x plus 2 divided by x plus 2. Okay, so this become mod of x plus 2 into x plus 2 divided by x plus 2 is 1. So this become e. Okay, this become e. Okay, now see here. If these two sides, left hand side and right hand side are equal, so what we will have? We will get the here power of e on both the sides should be equal, and the number before e, that is the coefficient of e on both the sides, should be equal. So here x plus 2 should be equals to 3. Okay, so mod of x plus 2, actually mod of x plus 2 should be equals to 3. Okay, now here, so mod we know, mod of x plus 2 is equals to 3. So x plus 2 will be what? Plus minus 3. Okay, so plus minus 3, correct? So what we will have now? Here x will be equals to what? Here we are getting the two values of x. Okay, so 1 when x plus 2 is equals to plus 3 and x plus 2 is equals to minus 3. Okay, so here the power of e is already 1 in both the side. Okay, so the coefficient of x should be, coefficient of e on the both the sides should be equal. So we have equated the mod x plus 2 with 3. Okay, so x plus 2 will be equals to plus minus 3. Okay, so we are getting two values of x. So x from here, 2 going that side, so 3 minus 2 is 1. And x from here, what we are getting? Okay, here plus 2 going that side is minus 2. So minus 3 minus 2 becomes minus 5. So when the x value is 1, so at that time, what will be the value of y? Y value will be x plus 2. Okay, so here y will be 1 plus 2, that is 3. And when x is equals to minus 5, so what will be the value of y? Minus 5 plus 2. So y value will be minus 3. Okay, so minus 5 plus 2 will be minus 3. So we are getting 2 points. One point we are getting 1 3, x coordinate 1 and the y coordinate 3. And another point we are getting b, x coordinate minus 5 and the y coordinate minus 3. Okay, so this curve, this line y equals to x plus 2 is intersecting this curve at how many points? 2 points. One point is 1 3 and another point is minus 5 minus 3. So A was saying that this line y equals to x plus 2 intersect the curve whose differential equation is this, given differential equation. So we have got this equation of the curve. It is intersecting at 2 points. So one exactly at 1 point is wrong. So A is wrong, and exactly at 2 points is correct. So B is correct. Okay. Now we'll check the options C and D. So option A is wrong and option B is correct. Okay. Now we'll check the options C and D. Okay. Now see here. What is the C telling? That this y equals to this equation of this curve, y equals to x plus 2 whole square, is intersecting this this curve. Okay, that is the what curve we have got by solving this differential equation. Okay, that curve at what it intersect means either one point or any number of points. Okay, we have to check that whether this curve is intersecting this curve at any point or not. Okay, we have to see that. Okay, so I am putting, so now I am doing the checking the option C. Okay, so putting y. So if this equation, this curve will intersect this. So here for placing the in place of y, if I substitute x plus 2 whole square, then both the side of this curve has to be equal. Okay, so I am putting y equals to x plus 2 whole squared in equation 2. That means the equation of the curve that we have got. Okay, in place of y, I am putting x plus 2 whole squared. So what we get? So we get 3 is equals to mod of x plus 2 whole squared. So x square we know is always positive. Okay, so the mod of x plus 2 whole squared will be x plus 2 whole squared. There will be no mod sign because this will be always positive. Okay, square is always positive. So y, I am writing x plus 2 whole squared. Okay, x plus 2 whole squared divided by x plus 2. Okay, so what we get from here? 3 is equals to x plus 2 whole squared into here it is cancelling, x plus 2 whole square divided by x plus 2. So this becomes x plus 2. Okay, now see, if this if the y is intersecting, so this left hand side and right hand side should be both equal. Okay, so here the power of E should be equal with the power of E on the left hand side and right hand side, and the coefficient of E, okay, on the left hand side and right hand side should be equal. So first we are equating here x plus 2, the power of E, x plus 2, and here the power of E is 1. Okay, so x is what? We are getting x is equals to minus 1. Now put x equals to minus 1 here. Okay, so this should be equals to then 3. Okay, so when I am putting here x equals to minus 1, so minus 1 plus 2 whole square. So what I am getting? I am getting minus 1 plus 2 is 1. So 1 whole squared is 1, which is not equals to 3. So this equation, okay, y is equals to x plus 2 is not satisfied this equation of the curve. So it is not so 1 is not equals to 3. So this curve equation is not satisfying the equation of the given curve. Okay, so it does not intersect. Okay, so therefore the conclusion is y is equals to x plus 2 whole square do not intersect this curve. Okay, do not intersect. It was saying in the option it intersect. It does not intersect. Okay, so the C is wrong. Okay, now we'll check for D. Okay, what is the D saying? D is saying that, okay, now see, what is the D saying? That this y equals to x plus 3 whole square, this equation of the curve, do not intersect the equation of the curve which we have got. Now let us check whether it is intersecting or not. Okay, now if it will intersect, then this equation of the curve will satisfy this equation. Okay, now putting, okay, so now let us check, putting y is equals to x plus 3 whole squared in this 2. So what we will have here, 3e will be here mod of x plus 3 whole square. So in place of y I am putting x plus 3 whole square. The mod x plus 3 whole square will be always positive. Okay, so this will be out of the mod sign, x plus 3 whole square, and here for y I am putting x plus 3, okay, whole square divided by x plus 2. Okay, so if this equation is satisfying, suppose intersect, then here this should be left hand side and the right hand side of this equation should be equal. Okay, now we are not getting any value of x which is satisfying here. The power of coefficient of e is what? Here x plus 3 whole squared. Okay, whole squared is equals to 3. And what is the power of e here? Power of e is here x plus 3 whole squared, x plus 2. It should be also equals to the power of this. So you will not get any point, any value of x which will satisfy this equation and this equation as well. So since we are not getting any value of x which is satisfying this both, okay, so this y equals to x plus 3 whole square do not intersect. It is already saying it do not intersect. So it is correct. It does not intersect. Okay, so the correct options are B and D. Okay, so the correct options are B and D for the given question. Okay, so I hope that you must have understood the sum very clearly. Okay, thanks for watching the video. Stay fine. Thank you.